Thank you everyone for joining today's demo on BEEST tricks and tips. The list of topics will be displayed on your screen in this PDF file, and I'll be going back and forth between that and the BEEST program and the other programs that are on the screen, USFViewer and AirNet. I'll be discussing some of the possibly lesser known features of the BEEST software today with you. At the end of the demo, we'll have a question and answer session. So the first program that I would like to show today is the AirNet program, and a couple of things in that program. The first one is the air surface options that are available to you. You basically you can import a file of somebody else on the air surface, but most of the time, if you're running it yourself, you have two options, which is store it locally on your computer or over the internet. And what the internet option allows you to do is that you don't have to download your own data files for air surface. If your project is within the continental United States, we have saved those files on our server, and you can run air surface over the internet on our server. So what this option does is it saves you the time needed to obtain data files for air surface. So you just select this option, go to the air surface tab, and run it as usual. And after that runs, the output tab is populated for you, just as if you run air surface on your computer, which is the local option. The other part of AirNet is that now you can export your metadata, your Met station into Google Earth from AirNet, and this is done through the file menus export entry. So let me, for example, select the surface station and click OK. And AirNet will now go out to Google Earth and show me where the metadata station is located. And speaking of the Google Earth, there used to be two versions of that, the free version and the paid version, which they called Google Earth Pro. But about 2 months or 3 months ago, Google made the Pro version free. So now you can download and install the Pro version, and you don't have to pay for it. This brings a few additional features in where you can go on Google Earth and what kind of data you can display. But again, the Pro version is now free for download. Next, I want to take a look at displaying the model outputs in BEEST and USFViewer. In USFViewer, I have run an example model scenario here, and I have several sets of outputs in my grid. What I can do in the grid is actually sort and filter the outputs just like in Excel. To sort them, I would just click on a column name, such as concentration, sort them in ascending order, then just click it again. Actually, that's right, ascending order, and then click the same column again to reverse this order. And that can be done on any one of the columns in this grid. The other thing that can be done is filtering. go to a column and click a black triangle that appears on the right side of it, you'll see the filter options that are similar to ones you would see in Excel. In this example, let me go ahead and select only the all source group and hit apply. And now I'll only see the outputs for that source group. And these guys will be hidden. If I go back to the filter and tell it to clear, the whole set of outputs will be displayed again. In the BEEST program itself, we can now also export outputs to Google Earth. And what you would need to do there is go to the display your model outputs, and then click the button in BEEST called Export to Google Earth. That will take your concentrations and actually it will display your sources, buildings, and output concentrations in Google Earth. And by default, what it will do now is to, when I zoom in, you'll see this. What it will do by default is to export the buildings and stacks in 3 dimensions, which does, by the way, also when you're exporting inputs. So what I can do now is actually I can view my output I can view my output concentrations, and the building will be in 3 dimensions. If you don't want BEEST to do that, you want to display them in 2 dimensions, there's now an option. You click the Options button on the left side of the screen, and now there's a new tab called Google Earth Options. You can click the 2D export to not have the buildings displayed in 3 dimensions. And also, if you have contours displayed in BEEST, those will be drawn in Google Earth as well. Now when I zoom in, I'll see that I just have the footprint of my building here, but it's in 2 dimensions. Now the 3-dimensional display of buildings and sources also applies to exporting your inputs. If you do want to export them in 3 dimensions, you should be sure that the stack diameter is not 0, that it's positive value. Going back to the outputs though, there's also an option to display the radius of impact for your outputs. In this example, you would select a point, and then select the concentration value that you're interested in. For example, 50 micrograms. You would input that, click OK, and this will draw a circle for you, starting from that point and displaying displaying the distance to the farthest receptor that has the value 50. And then on the lower right, we'll also display the distance of that radius in meters. When you have this radius displayed, you can also do one more thing, which is to click the right mouse button and tell BEEST to write the receptors inside that circle to a CSV file, which you can open in Excel. So in this case, I'll go ahead and tell it to save all receptors to a file. give it the file name, and then I can view that file in Excel and see just the receptors inside the circle. You can also select a different point for your center coordinates or a different level as desired. If you have the Surfer program installed, that's an additional option for exporting your inputs or outputs. You will need to specify in the preferences where that Surfer program is located on your computer after installation. But when you do, there's a button both on the input side and output side called Save Surfer Data, which is in the second row. And when I click that and click OK, BEEST will save my data and open the Surfer program to display it. In this case, it's just the inputs, which is our facility and the surrounding receptors. Then in Surfer, you can change the way these labels are displayed. You can change the way that these coordinates are displayed and so on to create a plot. The Surfer program also comes in with a free demo version and the paid version. What I'm displaying here is the demo version, which is the free version. Also, if you have installed our Screen 3 interface, you can click the button here called Run Screen 3, and BEEST will allow you to, and BEEST will actually let you run that using the inputs that you have set up in BEEST. You will not have to create a separate. You won't have to create a separate Screen 3 file and copy the inputs from BEEST to that file. BEEST will allow you to select the source you're interested in, select the building you're interested in, and how far you want to go out to in your Screen 3 receptor grid. In this case, that's going to say 500 meters. Then BEEST will run Screen 3 for you in the background and will allow you to view the outputs right within BEEST. Both the graphical and the text output. So this can save you some time, so that you don't have to copy all the inputs into Screen 3 multiple times. You can just select the source and building you're interested in and run it for those inputs. I'm sorry, and run Screen 3 for those inputs. Next, I want to go over some of the options for processing elevation data in BEEST, which is needed for the AirMod and IC models. And our current recommendation, and the elevation data files come in two flavors, DM and NED. We currently recommend NED since these files are being updated continuously by the U.S. Geological Survey. And the DM files are not being updated anymore. I think they haven't been since about 2011 or 2012. So I recommend downloading NED files and using those in AirMap to process your elevations. Also, formerly, if you had DM files, you would usually go to the terrain options in BEEST. You would select your DM files. Then you use the button here on the toolbar to calculate elevations. Now you should just download your data, which will go in a minute, and then go to Run AMAP to select the data file, whether DM or NAD, and Run AMAP. Running AMAP is now the recommended way to calculate elevations. And I also want to show you a new option in BEEST for obtaining those files. If you click this red button tab called Calculate Domain, or if you go to Run AMAP and then click Calc DOM, you'll see this form for telling BEEST how much elevation data you will need. On the bottom here, you'll be able to enter coordinates for the data you want to obtain for your modeling project. And then the next step is simply to click this Download NAD button, which will take you to the USGS website for obtaining the data. So now you would simply specify the coordinates of the area for which you want to download the file. Go into the Calculate Domain in BEEST, and then tell it to download NAD. And that will take you straight to the website where those files are obtained. Now these coordinates are default coordinates calculated by default. You can change those before clicking that button. And then if you want to see how much data you might need to obtain, what you can do is click on the Show Terrain Limits button here in the toolbar, and then zoom out until you see latitude and longitude coordinates in BEEST. In this case, I think BEEST recommends that you download this coordinate right here between these two latitudes and longitudes. And you can adjust that as needed if that's too much data, or maybe if it's too little, depending on your model setup. So again, the button for showing the latitudes and longitudes for the elevation data is the Show Terrain Limits. The button for actually downloading the data is this red button called Calculate Domain. And from there you click Download and obtain the elevation file for use with AMAP. Next, I would like to show to you a few of our features for navigating this graphical screen and displaying sources and buildings. On the left here we have the zoom in and zoom out buttons, which are self-explanatory. The zoom to selected area button allows you to draw a rectangle, and then BEEST will zoom into the area within that. And then the pan allows you to drag whatever is on the screen left or right to move it as appropriate to display things that maybe have been left off screen after you zoomed in. And also once you do see this, what you can do is click the right mouse and use the Find menu. For example, to locate a building at a site that has lots of buildings or lots of sources. Let me go ahead and I'll click on building. In this building, for example, I can select a building, and then tell BEEST to find that in my modeling project and go to that building, which is the Find and Zoom button. It will do that for you. It will also gray out the other buildings and sources so that you can see exactly where the building is located. Building or source, actually. If you go to the Find menu again and click None, it will it will display all the buildings and sources normally. And I can do this again to locate, for example, a source such as this middle source here. If I just click find, BEEST will not take me to the source, but it will highlight the source on the screen. Again, find and zoom will also zoom in on the source you're building. As you can see, there's not an option here to find a receptor, but there's another way to do that, which is to click the Display Overlay Grid Lines button on the toolbar on the left. What that will do is display UTM coordinates for your easting and northing in the model. And then you can use those to move to the separate location that you're looking for. Now once these coordinates are displayed, if you click the down arrow on your keyboard, the grid becomes not as dense. If you click the up arrow, it will become denser. And these are UTM coordinates, and they can be used to locate a receptor that you're interested in. I also want to show a couple of things on the source grid. First, this allows you to import data from Excel. If you have an Excel file set up, you would copy data in Excel and paste it into BEEST. And as long as you have the same column set up as in the grid here, everything will transfer into BEEST. In some of these columns, you see units such as meters or Kelvin. If you click on the unit, or so, for example, this velocity meters per second, if you click on the unit, BEEST will convert the unit to feet per second or knots or miles per hour. And then if you keep clicking, it will go back to the original unit. So let's say meters versus feet in for the stack height. So if you have your stack heights in feet in an Excel spreadsheet, you can change the units here, then paste the data into BEEST, and it will be pasted in the appropriate unit. You then need to see that in meters. I'll just click again a couple of times, and BEEST will convert the values to meters. And also, if you need to add a few blank rows at a time, you can go to the Edit menu, the Add Rows, and the number of rows, and click OK, and they will be added for you. And finally, I want to show a few more things in the graphical view. Going back to the graphical view here. One is that after you have donor building or source, you can right-click on that building or say if it's an area source and say Edit Corners. This applies to fence lines as well. Once you do that, the corners will become the building or area source you're editing will become highlighted, and you can click on the corners and move them around as appropriate. And let's actually delete a corner here. And once you're finished moving the corners, just click the mouse button anywhere outside the building, and the new locations will be saved. Additionally, if you want to move the building, all you have to do now is just Select the building, click the left mouse button and hold it down, move the building to a new location, and release the button. This works for both building sources and tanks now. So just anything that you want to move on the screen, you can just pick it up and drag it to a new location. And finally, one more feature related to buildings is you can click the Show GE P5L button, select a building, and then click this Show GE P5L option on the menu. And what that will show you is what sources nearby that building might be in its downwash zone for a certain wind direction, in this case 10 degrees. If I click the right and left arrow keys on the keyboard, that display will change and it will show what sources are affected by downwash from the building or other wind directions, such as 300 degrees here. If you click this button again, that view will be turned off. So those are the tips for today. Thank you for joining our demo, and we will now take questions from the audience.